So as we look at these additional stoichiometry problems, it's not necessarily that they're different, it's that the wording or that they're harder, it's that the wording really requires you to kind of sort through some stuff and figure out what is required of you and what is not. And maybe what are some ways that you could shortcut or you could do the exact same work without maybe showing as much or taking up as much time. So here we have hydrobromic acid and iron, and we get these things right here. What mass of hydrogen bromide gas would need to be dissolved in 250 milliliters of an acid solution to dissolve 3.2 grams of iron at a certain pressure and temperature? So we've got gases, we've got solutions, we've got strong acids, we've got maybe molarities, we've got grams. Lots of things going on here. But what we need to recognize is they're asking about a mass of one reactant compared to the mass of another. So it's a mass to mass relationship. So even though they talk about non-STP and solutions and dissolving, it's really just a grams to moles, moles to moles, moles to grams problem. The other thing that in terms of the way that I've solved it is recognizing that there's a 2-to-1 mole ratio here. Instead of having it set up and spread out like this, I've put it into one simple step that I've got my molar masses, but I realize that it's 2 moles or 180 grams of HBr for every 1 mole or 56 grams of iron. As long as everything's carefully labeled and we're showing this as 2 times the 81, we can combine steps. But you need to be really careful that we know or that you know where those numbers go. Does the 2 go on the top or the bottom, and why and how? Which is why sometimes it still comes back to analyzing the problem and maybe really getting to the point of the problem than shortcutting it. But I did want to show that even though up here every single time I had them as separate steps, it is acceptable as we're doing this to combine steps if there is clear labels and if there's a clear connection there. Right here is a gram to gram ratio as well. We could have done this all in one step as long as we did account for that 2-to-1 as we did right here. This first one, we've got a mixture of phosphorus and chlorine reacting to make 2 different products. Find the mass of PCl that forms. This one is a little bit tricky because it doesn't give us the equation. And as we approach it, we need to recognize that it's still the amount of reactant A, the amount of reactant B, a limiting reactant problem. So there's 2 different products. That allows us to write the equation and then go back and do this. We know both reactants, we know both products. So by filling that in, that's where we get to this. We then can recognize and look at it just like a normal stoichiometry problem. It'd be totally fine to combine it into one step like this. It is mass to mass, and that's great. It's the same molar mass we're ending at. The molar masses here obviously are unique to the compounds, but the most important thing was taking this information to determine these reactants so that we can figure out that mole ratio. So we've got it there. Once again, the 2 answers mean that we're going to take the smaller one because the chlorine runs out as soon as we've made that 38.5 grams, and we don't have enough to make the additional remainder of it. This is one where we're really getting into a little bit more of a challenge. We've got a solution of silver and mercury. When we add sodium iodide, it is enough to precipitate all of the ions as silver and mercury iodide. And we know how much precipitate we have. But that precipitate is a combination of the 2. Find the mass of the silver iodide in the solid precipitate. So the first thing I want to point out with this is probably too challenging for an individual part of an AP question. They might take this and break it down into 2 or 3 steps, as I'm going to look at and do with you. Or this might be a great question for a lab to build the skills. But you're not going to have a single part where you're just going to grind on one part of a question for 10, 15, 20 minutes to try to solve it. But what we're thinking about here is what relationships do we know? There is not a single reaction that says what ratio these react in, Some of the iodide goes here, some of it goes there. It goes to two different reactions at the same time, making a mixture. But I can recognize, based upon my molarity and volume, that there is a total of 0.122 moles of iodide that are in my sodium iodide that will therefore end up in my precipitate. What I'm going to do here is set up an equation to show that if I made a certain amount of moles of silver iodide, I would have a different amount of moles of, excuse me, mercury iodide. And when I look at this, the amount of this plus 2 of that is my moles of I2. And that's because right there, we need 2 I minuses when I'm doing that. So every 1 mole of HgI2 actually has 2 moles of I. So hopefully that relationship makes sense. There's 1 mole of AgI in every, or 1 mole of I in every mole of AgI, but there's 2 moles of I in every mole of HgI2. So then what I did here was made an equation that also showed me that the molar mass of silver times the moles of silver, the molar mass of mercury iodine times the moles of mercury iodide told me how much solid I would have. So I made an equation up here that was in terms of moles. That told me I knew how many moles of iodide I have, and I could think about how much, or I could define some variables in terms of silver and mercury. And then here I think about how many grams of solid I have, and I define that in terms of grams and moles there. By taking this equation and solving for x, or I could have also solved and substituted for y, I took an equation with 2 unknowns, another equation with the same 2 unknowns, and hopefully this sounds familiar from your algebra classes. 2 equations with 2 unknowns allows us to substitute and solve. So the mass there, right there, that's what x is equal to. Right there, now everything's in terms of y. I do my math, and I find out that I have 0.0538 moles of mercury iodide, which allows me then to know how many moles of silver iodide I have. So by setting these relationships, and really the key here is that I know how many moles of iodide were available, and I know that some of it went to one, some of it went to the other, but not in a 1-to-1 or 1-to-2 ratio necessarily, but just in some random ratio. But there was also a relationship in terms of mass that does connect to moles by using the molar masses. Putting those together, solve for the moles of mercury iodide, solve for the moles of silver iodide, and with the molar mass, solve for the grams of silver iodide. So a lot going on in that problem, but the keys are the moles, and then recognizing that mole ratios do lead to mass ratios by making the connections.